Hello, everyone. Welcome to the first edition of TestMu. We are at day 3, and the excitement level has not gone down yet. So I'm very happy to and I'm very excited to welcome Mayank Bhola. So the next speak, I'm very excited to introduce Mayank Bhola. Mayank is a software developer at heart who started as a lead architecture at LambdaTest. Now he leads the tech and product teams as co-founder and head of products. Mayank has a vast experience building sophisticated products and robust backends. He is also passionate about designing microservices and creating software architecture. In this session, Mayank Bhola will talk about HyperExecute and how it solves the challenges of traditional cloud grids and help businesses achieve quicker go-to-market. So without further ado, let's welcome Mayank to the stage. Mayank, the stage is all yours.
Thank you so much, Abhishek. Welcome, everyone. It's really great to see you all on this day 3 of our first ever edition of TestMu. Really excited to see all the support from the community as well as the participants. So I'll not waste a lot of time in this. I'll quickly jump over to sharing my screen and we will talk about the test orchestration. So I'd like to start by thanking our community for building such great tooling for testing the software. Starting from Selenium, going with Cypress, Playwright, APM, all these were very, very fundamental to enable the world to do testing. And we have come so far that now these are uh, very critical components of an entire software development cycle that we cannot move ahead with them. And with all these important and critical tooling, there was a requirement for the infrastructure that could provide these tooling to run at scale. And along this journey of last 1 decade, we have seen a lot of different testing ecosystem building over these open source tools. So definitely these have been fundamentally important in providing us a root tooling to do all the testing that we are seeing today. uh, Time travel to today, and then we see that right now the problem is at testing at scale, because obviously these are very powerful tools. And if I have to draw an analogy between the Docker and the container world, Docker absolutely gave us very powerful tooling, but there was a missing orchestration layer which Kubernetes filled in the place. Similarly, in the testing world, obviously we have so much mature tooling. We require an infrastructure that can provide these as a base and provide us to run a very robust platform, so that the testing can be done without focusing on the underlying details of setting the grids up, setting the underlying infra up, and providing a very good ecosystem which is providing a great visibility. So now we know that the infrastructure is so important. Along the line, we see that since the testing was accepted as a mainstream in the software development life cycle, and people started testing at scale, with that there was some experience that the infra didn't catch up so well, and there were some challenges with the conventional infra, starting with the slowness of the speed. So in our experience of serving different customers, we had various different kind of learnings that we had, and that made us improve the platform. But one of them was the slowness of test infrastructure. Now what typically happens is that whenever a developer or a software testing engineer tries to run some test cases on their local systems, the laptops, the desktops, they run very, very fast as compared to if they can run these test cases over a remote infra platform. Now that's a very big problem. Why? Because when you run entire test suite on your local system, it typically tends to finish in minutes. But when same thing is thrown at the cloud, it start taking more time every test. Definitely, cloud infrastructure has very good benefits as compared to the local one, because everything is being managed, the scalability is there. But then the compromise on the speed is actually not a good bargain, and this has led to various different kind of ad hoc development that the teams had to do by their own because they knew that Selenium was working fine, but then the way it was arranged on the remote cloud grid was not very good enough. Then let's talk about the brittleness. Even though the Selenium is providing very good support to capture every single log and has various different kind of APIs, the problem is that if this infrastructure itself is not very robust and resilient, it's going to provide a very poor experience to the end developer. Now, in today's modern testing stack, there are lots of moving parts, and it means that even if we are targeting for very high reliability, it could happen that one or more component could fail at a time. But then, if the testing platform is not resilient enough, it will be very difficult to provide a very seamless experience. Because what will happen is that out of 1,000 or even 10,000 runs, there will be multiple scenarios in which one of the component failed and the entire test case is actually failed back to the user. Now it becomes a great question back to the developer. What failed my test? Is the test case the culprit? The application and test is the culprit, or is actually the tooling that I'm using? Going forward, in today's complex scenarios, there's very rare chance that we are just going to hit some APIs and just test out the web application. There are so many components involved, and teams have become very, very matured in preparing their test data and providing a mocking environment that they require multiple other kind of access to the underlying operating system. Now let's take an example that we have an enterprise application and it requires the users to provide client-based certificates. Now in a traditional testing cloud grid, only the access to the browser is available. And it makes it very, very difficult to simulate such kind of cases where we could actually fiddle with the underlying operating system. And this forces back every developer and team to create their own kind of software testing infrastructure. And then they start to fall down the spiral because obviously they have the additional overhead of maintaining that test infra in order to focus on writing the good test cases. And finally, the flakiness. Now, if the testing platform itself is flaky, we are adding a third contender to the flakiness level because now on every test failures, we have three things to doubt at. One, the test case itself. Second, the application. And third, on the infra. It's just adding more and more complexity, and it's actually increasing the time to market because debugging and triaging takes a lot of time. And I would like to spend some more time on talking about the slowness. And we try to dig deep into the problem, what causes, because ultimately we do realize that running test cases on the cloud is a way to go. We shouldn't run them on a local system or self-managed system because cloud has so many other benefits. But then the way typical cloud grids are set up is can be explained by this diagram. It's more or less the same across all the kind of software tooling regarding testing. We can talk about Selenium, we could talk about Playwright or any other famous tooling that we have. So typically what happens is that there's a script that the developers run on their system or on their CI system, which is sending out some requests. So in a typical test case, as we know, there are a couple of use cases that we are trying to operate from the user side. Every such use case is being sent over the wire in form of an HTTP call or some other network call. Now, what happens is that the remote testing infra has a component which is called the request gateway. This component is responsible for accepting some commands, and then they are being relayed to plethora of different microservices, which are responsible for provisioning some remote infra. In case, for example, if somebody wants to test out their website on an Edge version of 92 on, let's say, Windows 10, and somebody other wants to test out Firefox 78 on macOS Ventura. Now, these microservices would provision an infra for them, and then whatever the user is sending to the request gateway is being replicated to these virtual machines, which are housing the web browser. And finally, the web browser is going to communicate this to the application under test case. Now, as we saw that for a single command, our data has to traverse through all these different components and then back to it again. And these microservice layer in between, which are responsible for providing you different kind of logging, observability, are adding more delays. In order to make these testing infrastructures reliable, typically the providers just distribute them over different regions. Now, in such a highly distributed system, what could typically happen is that I'm sitting in India and I want to test out an Australian website. And it could very easily happen that my requests are going to the US based hub because that is the least being used right now. And then the infra that is being provisioned for me is sitting in the Europe. And when this happens, I'm going to face the worst latency in this testing cycle, because whatever I'm sending from commands is going to traverse the whole world twice before actually getting back to me. And if we focus closely, what are we doing in this is just waiting for the network responses. And this alone thing entirely makes our test execution very, very slow. And not just slow, as you can imagine, if there's a degradation between two components, it would actually mean that my entire test suite can become more flaky. Because when I write these test cases and run on my system, I do not have this kind of a setup. Everything is there in my system, and there is no such degradation, right? But when I throw it on the remote cloud grids, they typically tend to add this flakiness as well as failures. Now, this is a very big problem because this is the way that testing grids have been set up. And if we look a deeper, let's talk about the serious business of testing where we have large teams. We have around 1,000 or 2,000 developers who want to run tens of thousands of test cases every day. So the problem is not just at the speed now, it's more about various sophisticated paradigms that I'm applying to my testing. One of them is the complex workflows. Now, in a typical enterprise testing, there are like thousands of test cases which are connected together in some very sophisticated ordering, which could mean that one test runs and then parallel two other test cases runs. And finally, after the result of them is getting calculated, the fourth and the fifth test will start to trigger. Now, it's very difficult to maintain such logic under the code. Typically, there should be an alternative way in which the directives should be provided by the platform itself. It should be very easy to define such workflows, because the time spent in maintaining these workflows is just getting wasted, and it's seeking out the crucial time that should be spent into crafting the test cases. Moving further, now if we are running tens of thousands of test cases every day, and if we have to find out the root cause of some failures, like 5 or 10 failures, it's like finding needle in the haystack. Typically, the testing infra right now is just throwing logs at us. It's very difficult to find the actual cause. It means reading thousands of logs offline before we actually get on to the root cause, which actually means that if my test case fails, I'm going to spend a lot more time in figuring out the root cause than going back and fixing my test case. And then, as we have moved along this journey of doing more testing and we talk about shift left testing, what it has mean is that the number of test cases entering into our repositories have increased by many folds, which means that we shouldn't be running all the test cases every time. Now, the platform itself should have this capability where it can somehow filter out which test case to run. Because ultimately, the software developer shouldn't be focusing on this. They should just only be focusing on when to trigger the test cases, as well as they should just focusing on writing more and more test cases. The platform itself should have to make the decisions what to run and when to run. And finally, the observability. Now, it's little bit related to the debugging nightmare problem, but then it's more about uncovering the patterns. Now, when we are running these thousands and thousands of test cases every day, what could happen is that there's some degradation at a minute test level can start to creep into our system. It would mean that the test cases are still passing, but they have significantly started taking more and more time. Now, it's very difficult to find out any such degradation at a large scale, because if a test case that used to take 1 minute is now taking 1.5 minutes, it will be hidden in my total end-to-end time. But then the platform itself should have those core observability traits that help us uncover these problems over there. The platform, it should able to define some anomalies and send it back to the user, so that way before the actual test case start becoming a problem, the platform itself should notify so that the developer can take the appropriate action within the time. So now, with all these problems, one thing that stands for sure is, again, we're going back to our analogy with Docker and Kubernetes, is that we need a core orchestration layer. What means in the statement, what I mean by this statement is that the platform itself should be able to take the load of executing all the test cases smartly and intelligently distributing them across different nodes in which could actually mean some Docker containers, virtual machines, emulators, simulators, as well as real devices. Now, why this should be on the platform? Because platform itself knows the current state of the entire system. Now, since these are distributed systems and are separated over multiple tenants, failure in the underlying components of the cloud is very common. But then this failure should not be traversed back to the user. The platform itself should be resilient enough to make sure that a test case which got failed because of the underlying infra problem should be rescheduled again, so that the end user is oblivion of the fact that some failure occurred in the middle. They should only be concerned about seeing the failures that were caused due to their logic or their application under the test. So then the idle orchestration should actually take all the test cases from back from the user and just ask for the concurrency. Now, what it means that if I'm a user and I'm saying that I want to run 10,000 test cases, and I want to distribute them over 1,000 virtual machines, I shouldn't be just blindly running 10 test cases over a single machine. I think the reason is very simple for you guys, because not all test cases have a same execution time. What could happen is that some of the test cases take few minutes and the other test cases start taking like few seconds or some hours. Now, if I'm just blindly distributing them, what could happen at one day is that all my long running test cases can get scheduled into a single node. And in that way, that single node will be the blocking for my entire job to pass or fail. And I'll be just wasting my time because my resources were not being used efficiently. But if we look very deeply, it's very difficult for somebody to manually do this by hand, because on every commit, our test case behavior is getting changed. So it's up to the platform that uses the historic analysis as well as the current parameters that were sent into the test case to decide the correct order of the test cases, so that we are utilizing the underlying infra in the most efficient manner. And exactly this is what we have attempted to do in HyperExecute, which I'm going to talk about in next few slides. But then again, sticking with the core orchestration thing, the platform itself should be able to decide where to schedule a test case and what to do if the underlying infra gets failed. And talking more on orchestration, there are some other directives that we have added in HyperExecute, which we feel that should be there in an idle execution platform, are the smart ordering and the retries. Now we already know that it's a bad practice to actually just retry a test case to see if it's failing in the next run or not. But it's a very efficient way and a very a time sensitive way to actually figure out if my test case is flaky. So what we have seen in our experience is that most of the teams have written a logic inside their code base that if a test case fails, they are going to retry it. Now, instead of doing this by hand, we have added into the core execution fabric. The platform itself should be able to handle that. As a user, I should only be worried about telling the platform how many maximum retries should happen, and everything should be taken care automatically. So what it means, again, if my test case fails, platform should only be able to retry that failed test case again up to 5 times or 6 times or 7 times. In that ways, it becomes very much clear to you that which test cases are flaky, and for the platform itself becomes very easy to report it back. And then finally, talking about the smart ordering. Now, typically what happens is that if I'm running 100 test cases and my 80th test case failed, I am most probably interested in knowing that after my current fixes, is my 80th test case still passing or not? So I'll trigger it again. But then unfortunately, I'll have to wait for the first 79 executions before my 80th test case starts executing. And this is what we have tried to solve in HyperExecute again, where we say that the platform itself should order the test case in the smart order, so that the consistently failing test cases or the previously failing test cases should be scheduled first, so that the end user gets the feedback very, very fast. Now, along with these orchestration features, the core execution fabric of an idle orchestration platform and the execution platform should also have the capability to control and modify the underlying environment to execution. What it means that I might need to run a MySQL server. I might need to generate a special SSH key inside the virtual machine in which I'm triggering the test case. All that should be available back to the user in form of smart directives, so that whenever we are running a test case, we should be able to clearly define our execution environment requirements. I could be I could want a machine with a GPU. I could want a ramped up memory, or I could say that I want to install these dependencies before my actual test execution starts. If that is available back to the end developer, they'll be able to create much more robust and thin layer of YAML directives which can define their environment in a static way, and which again gets committed into the source repository. So now the communication between the DevOps, the cloud providers, as well as these engineers is actually getting reduced, because the test developers themselves have this complete flexibility into their hands on how to define and control their execution environment. And finally, the core execution fabric should also have this deep analytics and the error classification, because it's not just important to throw back the logs at the user. The platform should spend much more effort into categorizing and filtering those logs so that the only important and critical information gets back to the user. And not to forget, all this information should be available to the user in real time. Because if I am waiting for my entire test suite to end just to figure out that there was a syntax error, I'm just completely wasting my time. I'm just block my infra. So the best execution fabric would actually have to stream all the logs and provide all the logs in the real time, so that when an error happens, the end developers and the concerned parties should be aware of it as soon as possible. Now, taking case of HyperExecute, this is a very simple example of how this entire test orchestration can be taken care by in a simple YAML workflow file. So as an end user, I should be having the capability to define my environment, in which case, for example, we say that it wants to run on Windows, but then we also want to run some scripts. In this case, it's very apparent that we want to install some Node.js dependencies. But then instead of me telling to platform which test case to run or how to run them, I just only focus on telling them the parameters that the platform itself can use to discover the test case. So in this examples, we are just trying to run all the feature files inside a certain directory for the JavaScript. Now the platform itself is having that intelligence on how to discover and run these test cases in the most efficient manner. And finally, if you want to just override the command while running the test case, it should be also available as a part of this defining YAML. Now, with all such features in the core execution fabric, what we ultimately gain here, these are the non-linear gains. And why this is important, because we have seen most of the arguments that if we want to just speed up our execution, we can increase the concurrency or increase the parallelism. But then we have to think on the flip side as well. If in order to make my test execution twice as fast, I'm spending that twice more money, I'm not getting returns, because this is not sustainable. And for very big enterprises, this is not even an option. They have a defined budget. They cannot just throw twice the amount of money to make sure the test execution is happening in half amount of the time. So the platform itself should be having that kind of capability that allows the end user to gain more performance and less latency by having a very little amount of extra investment on top. And the investment as well as the growth should not grow linearly. This should be completely non-linear. And this is what we define as a benchmark of a very smart orchestration platform, because ultimately this is the end goal. If we are able to get back all the returns, we are able to justify all the investment put into using this such a kind of a platform. And then again, a very small glimpse of what we have tried to figure out in terms of the observability that can help us as an end user is such kind of analytics and metrics. This is a very small glimpse, but ultimately, as we know that if we are running the same set of tests on every commit, we should get a very broad eye view of what's happening out there, which commits are failing those test cases, which are not. And then finally, a various different kind of charting as well as anomaly detection features that can tell us which test cases have been consistently failing or which have started taking more and more time. So at this point in time, I would like to just quickly show you a very small demo on how to use this kind of a platform, in this case, HyperExecute. So I'll not take much time. This is a sample YAML that we have created. It's almost in the same lines of the example that I showed. But in this case, instead of using JavaScript, we're using SpecFlow in C#. And we are doing various other operations on our environment. For example, downloading the NuGet packages and building our application as well. So With this YAML, what we all need to do is just hit the CLI, and the CLI is going to take care of everything. Packaging the test scripts, it's going to provision the infra, it's going to orchestrate, and then just provide logs back to the end user. I'll uh, I'll quickly show you the previous executions so that we get a fair idea of what benefits this kind of a platform can provide back to the end users. Let's take this for an example. Now this job definitely failed, but then what this kind of platform can do for the end users is this kind of a thing, because where we know that this is a test which is actually flaky, but then we know that it might run. So in this case, the platform itself retried up to x number of times, and in the final one it ran. Now it's a great benefit back to the end user, where it can know that all the test is passing, but then it's a serious problem and should be fixed immediately. And apart from this platform also has a real-time capabilities of providing the end terminal logs. Now, this is in contrast to the traditional grids where you only have a view of one part of the test execution, that is the browser. But the real exceptions and the real problem of these test cases gets appeared in the stack traces as well as the terminal outputs. So in this platform, we have made sure that for every single test case, we are capturing 360-degree view that includes the terminal logs as well, which gets streams back to the user in real time. Now, in such cases, it's very easy for somebody to figure out what went wrong in case of some exceptions out there. For example, if you see over there, we have a stat trace, and the user, as soon as they see it, they can immediately go back and fix the problem and run it again. And then in such kind of a workforces where some of the test cases are not getting passed even on multiple retries, the platform takes care of scheduling these test cases on a separate node so that other test case executions are not getting impacted. And this is how the end user can just focus on writing and fixing their test cases and leaving everything back to the platform. And apart from this, we also made sure that we are having some artifacts. So if your test execution generates some artifacts, the platform itself will capture them and present back to the end user in a very easily consumable form. So that was a very brief glimpse of what this platform can do. And I hope we learned about what should we expect back from a very mature and a resilient test orchestration platform. So back to Abhishek. Thank you, everyone. I would love to answer any questions if you guys have.
Thank you, Mayank. Thank you, Mayank. That was a really insightful session. I'm sure a lot of our viewers have a lot of questions. What I'm going to do right now is show this question on your stage. You can answer them.
Sure.
Here's the first question.
Got it. So one of the key feature that sets it apart is that, as I explained, it's not just a plain execution platform. It's an orchestration platform, which means that you can just write the test case and let it distribute the test case and execute them in the most efficient manner, along with allowing you the ability to control and customize the underlying environment. So as an end user, you can clearly specify what needs to be done to set up this environment before my test case starts. And in my opinion, that is one of the biggest flexibility that we give to the end users in such a kind of a platform.
Great. Let's take the second question from Manish.
Absolutely. So if we have focused deeply on the presentation, what we have shown here is that this kind of a platform is very agnostic to the testing technology. It means that it's back to the end user, and they can configure it to run any of the different kinds of test cases. It could be Selenium test case, could be performance test case, or an API test case as well. So definitely a different kind of runners across different operating systems can also be configured in such a kind of a platform.
Great. Manish has a second question as well.
Sure. Yes, so it definitely supports a node auto scaling, but even better than that is that if an end user can specify the desired concurrency, then it can automatically distribute the test cases. So node auto scaling typically happens when we are streaming the test cases. So definitely, yes, this can be provisioned, but in most of the cases where the end users know how many test cases needs to run, it can be directly fed into the system, and system can pre-compute the required nodes to execute them in the most efficient manner.
So Avinash has a question. Is the documentation available?
Absolutely, the documentation is available, and we also have various GitHub repositories that demonstrate on how to write different kind of test cases over that. You can find them over our official website. We can send over the link in the chat.
Great. So, Arun has a question. What is the right count for the retry test executions?
So I think that typically depends on the test itself. We have read that some developers from Netflix TV testing app have this magic number of 35. So they try the test case up to 35 number of times to see their status is constant or not. But then again, it typically depends on the criticality of the test case and the flakiness level. But in our experience, anything above 5 is a actually big red flagger. So if your test cases are taking more than 5 retries to get passed, those should be fixed immediately.
Great. So, Soumya has a question for you. Can you touch upon plans for releasing mobile support on HyperExecute?
Absolutely. So we are bringing the mobile support in terms of simulators and emulators in the last quarter of this year.
Great. So, Manish has one more question. Is it SaaS based or we can deploy this on our own KA clusters?
So both. We have our SaaS-based offering, but then we also provide on-prem installations. So you can pick up on any of the public clouds like AWS, GCP, Azure.
Great. Arunabha Paul, one of our speakers, how to try out HyperExecute and what is the license price? Also, can we use this for execution for any client project?
So I'll start answering from the last. Yes, definitely. This is something that we think the HyperExecute has a very good use case for. So you can definitely set up a master cluster of HyperExecute and run execution for your client project. And in this way, you can actually reap off many of the benefits of the core execution platform, so that you don't have to set it up yourself or manage it yourself, and then you can sublet it back to the customers. So the way to try out HyperExecute is very simple. We have a great onboarding. So as a user, you can just log into a website, and we have some examples to try out directly on the web. And for the license pricing, we have dedicated pages around there, and we can send them again on the chat.
Great. Jatin has an interesting question. Let me just show this on stage. So LambdaTest has both an online Selenium grid and a HyperExecute grid. When should someone opt for HyperExecute over the online cloud grid?
So that's an interesting question, and I would like to answer this by taking an analogy. So we have both CPUs and GPUs, right? But that doesn't mean that by the advent of GPUs, the CPU market got shrinked. No. So there are different use cases. In case that you actually want to do a truly cross-browser testing back from XP to the latest macOS Ventura, then the standard Selenium grid is the answer. But when the use case starts to narrow down, where you don't have to test out on various different kind of browsers, but just focus on the performance and the core use case, and the speed is becoming a critical factor for you, as well as debugging is becoming a nightmare. That means that you need to go on a very sophisticated orchestration platform, and there we recommend using HyperExecute.
Great. Rajendra has this is our last question. Is the predictability capability into which actually makes the execution fast? Like only execute the test cases depending on the code change, but learning from build management tool.
Interestingly, yes, this is what we are building every day and improvising every day. And in starting, we have provided some semi-automated mechanisms in order to tell what kind of changes happen into the system. But then, yes, this is the end goal. The platform should able to identify the uh, the test cases to run automatically, and we are getting back to it by end of this quarter.
So thank you, Mayank, for clearing all our viewers' doubt. Thank you, everyone, for joining in the session. Before we go, I just wanted to thank our partners for helping us and supporting us throughout the event. Please do check out their booths. They have really good swags for you. They have a great offerings that you can check out. So thank you, everyone, for joining in this session. Have a great day. Happy testing.
Really great to have you all. Thank you so much.
Thank you.